I spent 4 hours setting this up before I hit the wall. Local Claude Code, fully offline, zero API cost. It all works, but there is one thing that decides whether you get a genuinely useful AI coding assistant or a model silently degrades mid-task and never tells you why. Most guides skip it entirely. I did not know it existed until it bit me. This is the full reality check: what works, what breaks, and exactly when to stop and use the API instead. By default, Cloud Code is talking to Anthropic server. Every message, every file it reads, every edit it makes, going through the API. It is built per token. For casual use, that is fine. But if you are working with sensitive code, you would rather keep on your machine, or you are running long sessions and the cost is adding up. Local makes sense. No cost, full privacy. The setup is genuinely simpler than most guides make it look. But the part those guides consistently skip: whether your machine can actually handle what you need it to run. So let's do this in order. Setup first, hardware reality check after. That way, you will know exactly what you are working with before you commit to anything. First step, go to ollama.com, pick your OS, hit download. Complete the standard installation process. Once it is installed, head to ollama.com/library. This is the full model catalog, every model Ollama supports. Find the one you want, click in, and you will see different size variants. Those numbers in the name: 2B, 4B, 9B, that is billion parameters. Bigger means smarter, but slower and hungrier for RAM. I will get into exactly which size you actually need in a minute. And trust me, this matters way more than you think. Select the model you want to use. Then here is the command to pull. I already have it on my local, so I will just run this command. This one command wires everything up and drops you straight into a Cloud Code session pointed it to your local Ollama instance. I am going with Quen 3.5 9B model for this demo. No proxy setup, no config files, no second process to babysit. Cloud Code is running fully local. Right, let's actually use it. I have got a fresh React project, basically an empty directory. I am going to ask Cloud Code to build a pricing card component, 3 tiers, a highlighted popular plan, a CTA button on each. This is my prop. I am going to hit enter. It reads the project structure first, figure out what exists, then starts creating files. Basically same as cloud models. It created a file, but there is no project initialized. So I will ask it to initialize and setting up a server. Here it is. It started the server, but it is not working. So I will ask it to debug and fix it. Finally it is done. 3 tiers. The pro card is highlighted. This took a lot of back and forth, multiple prompts, multiple error fixes. This is not one shot and done. The design is also not great. So I will clean that up and add some animations without re-explaining anything. Let's see if the context holds. It knew which component to change, remembered the color scheme, and added the animation. I did not need to re-explain it anything. That is the context window doing its job, working fine with the local model. So how does it remember? Honest answer, it does not. Not really. Every message you send, Ollama bundles the entire conversation history and fires it back to the model from scratch. Think it like handing someone a printout of whole conversation before every reply, instead of them actually remembering it. By doing this, token count grows for every single prompt. That is the history piling up. Quen 3.59b has 256k token context window. Claude handles 1 million. In a long agentic session, reading files, editing, running commands, each tool call eats token fast. When it overflows, the model quietly drops the old messages. No warning, no error. It just forgets what you were doing. Now here is the part that nobody tests properly before making claims. So I tested both of these myself, so you don't have to find out mid-project. Let me fetch the existing skills. I will run the remotion skill to see if the local model can handle it. The skill fired. It knows what is inside. It works, but it is not smart enough to design motion graphics on its own. It needs my input. Now, let's test MCP. I have GitHub MCP configured. I will pull 5 repos from my account. It is firing the MCP tool call. I am approving it, and there it is, fetching repo details through MCP. No issues. But keep this in mind. If you have a lot of MCP servers and skills configured, disable them or scope them into project level. Too many tools loaded up front means the context window gets eaten before you type a single prompt. With a local model that is already working with a smaller context window, this slows everything noticeably. And skills and MCP servers won't work reliably with 4B models. You need something bigger. This one surprises people. The local model has zero internet access, completely air gapped, no browsing, no fetching dogs, no checking versions. Its knowledge is frozen at its training cutoff. Ask it about a library that had a major update 3 months ago, and it will answer confidently based on old information. It won't say this might be outdated, it will just be wrong. Here is the thing, this is about the model, not Claude Code itself. If you install a web search MCP server, Claude Code can still search the internet. The MCP runs on your machine and passes the result back in. So live lookup are possible. That is not built in, you have to wire it up yourself. And if you are using this completely offline, secure environment, no network, the model works fine. Zero network dependency once the model is downloaded. This is a part that decides whether this entire setup works for you or completely wastes your time. Under 6B parameters, fast and light, but not reliable enough for agentic use. I know because I tested it. I ran Quen 3.5 4B model and asked it to write a code. It told me it created a file. Actually, the file did not exist. It was just printing code into the terminal and calling that as done. And the context was already failing apart at 50% of context window. Not even a half. 6 to 8B. This is the real minimum for Claude Code to be useful. Quen 3 8B or Quen 3.5 9B both have solid tool use support. This is what I am running in this demo. It works, but it is not fast. 14B to 32B. This is where it gets genuinely good. Reasoning quality jumps, complex multi-step tasks hold together, and the structured JSON output that Claude Code's agentic loop depends on becomes much more reliable. Bigger model, better structured output, better agentic behavior. That is the whole game. But here is what these numbers means for your machine. A 8B model uses around 10 to 12 GB of RAM on its own. A 14B model needs 15 to 18 GB. And your OS, your editor, your browser on a 16 GB machine, you are already in trouble. Let me be direct here because this matters more than most videos on this topic admit. This setup works if you have a machine with 16 GB RAM minimum. I recommend at least 24 GB. If you want to feel it snappy, then you need more RAM. You want privacy, you are doing short focused tasks, and you are not depending on the model knowing about anything from the last year or two. Then for you it works. It does not work if you are on a 8 GB or 16 GB machine that is already at capacity. It does not work if you need current library knowledge. And it absolutely does not work if you want the same quality you get from the real Claude API. Because a 9B local model is not a drop-in replacement for Claude Sonnet. So here are your actual options. Machine can't handle 8B plus model. Just use the Claude API. You pay per token, but you get the real model, the full context window, and none of the RAM drama. Want something free and cloud-based? Look at open source model through OpenRouter. You are running interface in the cloud, not locally. Your machine does not need to do the heavy lifting, and many models there are free or very cheap. Gemini also has generous free tier worth checking out. Local Ollama is one option. It is a good one if your machine qualifies, but it is not the only option. And for a lot of people, it is not even the right one. Two things worth knowing before you commit to this. First, RAM usage is brutal. I have got 24 GB RAM in my machine. Running Claude Code with a 9B Quen 3.5 model, it was eating around 15 GB of RAM. When I ran the same model directly in Ollama without Claude Code, it was noticeably faster. Claude Code adds overhead on top of the model. It is reading files, running commands, maintaining session state. If you are on 16 GB and thinking the model needs only 6 GB, I have got a headroom. Trust me, you don't. Not once Claude Code is doing real agentic work. Second, the knowledge cutoff is invisible. The model will never tell you when it's out of date. Ask it about package update, a new API feature, a breaking change from the last year. It will answer confidently based on whatever it was trained on. No disclaimer, no caveat, just the wrong answer, delivered with full confidence. If you need current information, add a web search MCP or switch to API where the model at least knows what year it is. If you have a machine for it, 24 GB RAM is recommended, and you want a private offline coding assistant for focused work. This setup is legitimate and works. Keep sessions tight and know what you are asking it to do. If you don't have the hardware, skip it. Use the API. It is more capable and faster. The constraint is not always model size. Sometimes it is RAM. Sometimes it is context window. Sometimes it is knowledge cutoff you can't see coming. Figure out which constraint is actually yours. And then this whole decision gets a lot simpler. What are you running locally? Drop your setup in comments.